All right. Hello, nerds. How are you today? I hope you can hear me fine. And if you can't, let me know. And I hope there's some constructions workers outside, so I hope you don't hear that. And how are you all today? Today we'll be taking a look at where we are at, which is the final testing phases, hopefully, for my relighting people while preserving details and taking care of color matching as well. And here we go. Here's the workflow, basically. What we have here is 4 of the same workflows, really. And what we want to do today is test the limits of it. So if any of you in the chat have any link to images they want to test out, then I would love that. But let's start with where we were at first. So we were at this point here. I'm gonna link down the link here in the chat. And in this video, we were talking about how we can relight products, and that's great because I mean, there's many more pictures of good morning. Hey, there's way too many pictures of products rather than picture of people that need relighting in the real world out there. But that workflow wasn't working quite well, but in terms of color matching and preserving details for relighting people. And the main issue of that was, well, first thing was that there was a jungle of nodes that was trying to take care of frequency separation in order to separate details and color and lighting and work on them separately. The other thing that was kind of wrong was that the matching, the color matching algorithm wasn't working quite well. And that's not because of the color matching algorithm and the color matching node. It was mostly because the histograms of, or at least I think it's because of that the histograms for the, oh, Marascot, if you want to send a link here, if you can, I don't know if links are allowed. I hope that links are allowed. Otherwise, you can send them at this email over here. I'm gonna write down this email here, andreabaioni.com. Yeah. So if you want to try and post links, you can try and do that. If you cannot, you can just send images via email to this email, and any of you can do that. I'm gonna receive them, and then I'm gonna. Oh, hello. Oh, you are the Korean viewer. Oh, okay. Let's see what that means. Let's check that out. Translate from Korean. Oh, well, that's annyeonghaseyo. Annyeonghaseyo. Yeah, that's the same as the other time. Yeah. Oh, wow, no, that's a long phrase to translate. Okay, I'm gonna look into that later. So, so the color matching wasn't quite working because of the mismatching histograms. Like the relit picture had, any relit pictures basically had widely different histograms than the source picture, the original picture. And so the color matching was quite scuffed. And now we are here. So basically where we're starting from is this picture over here on the left, which is quite small, I realize now. So let's do that instead. I don't know if this is someone real. I got this picture from a Reddit user. Actually, shout out to, let me check the actual name of the Reddit user. Help me. Let me check. That was Space Pixel, user Space Pixel, whose color matching nodes are absolutely fantastic. And I was writing on Reddit that I was about to publish my first custom nodes, and that was the frequency separation technique. And they already had some frequency separation. Well, they had some how do you call that, like detail, it was a detailer node basically that could hold details from picture to picture. And I said, okay, well, if you need that, no need to actually publish a custom node repo. I can just integrate what you need inside of my custom nodes. And they did, so that's great. But I ended up using mine anyway, and some of theirs as well. So I am using this picture that they provided, and it's a picture with some very, very harsh lighting. If we zoom that in a bit, you can see that the whole left side of the subject, right side for us, is very, very lit up, while the left side for us, right side for him, is completely okay, I've seen the email. Hey, Marascott, I'm gonna try your image after the intro. And so this is one of those test images that I really like, because it's it's instead of a spectrum where we go from really soft lighting to really harsh lighting, this is all the way to that side of the spectrum. So if something works with this image and works with soft light as well, then we kind of know that what we did was right, at least. So what I am doing, and what I ended up doing, was using this picture as the starting picture for my first test. And what I am doing now is splitting the frequency of the original and the relit picture, which is these two images here, with my own custom node. Actually, let me bring up the... I'm gonna link the repo. You can find them here, because I don't think they're on the manager. I don't even know how to get nodes on the manager. This is a first for me. Like, I've never developed a custom node. But I am splitting the frequency into high frequency, low frequency. I don't know why you can't preview the image here. It's not loading the preview, but it's loading here. It's basically the same. We have some details over here. I know they are very hard to tell, but if we go, for example, let's say to 5, we should be able to pick those up. Yep, we get some of them. You really have to squint a lot in order to see them, but they're here. And then what I thought, since we couldn't match the low frequency layer in terms of color quite well, oh, hello everyone who's tuning in, I thought about remapping the image 4 times. Well, the more the better, but you know, I started with 4, so I don't want to have like a way too cluttered workflow if it's not completely necessary. So what I did was just start from 0 and 1. This remap image range does nothing, because minimum 0, maximum 1 is basically the whole range. And starting from the second, we start going down with the light. Because let me show you what happens when you don't do that. Let's do a color match with the low frequency as a reference from the original image, and the low frequency as a target from the relit image. And let's hit preview. Well, how does that work? Do you work now? Did he update them? Oh, but maybe it wasn't this one. Color match. Maybe I was using this one. Image ref, image target. There we go. Yes, we were getting this thing over here. So, well, at this point we can probably just do that instead. But this is images, this is ref. There we go. Okay. But I've found that you get a much more precise blending. Like here, you can see that you're still picking up some of the light from the side, which shouldn't be there. Like there should be some light, but not as harsh, by remapping all like the picture like 4 times. One is basically nothing, one is 0.2 down from highlights, one is 0.4 down from highlights, one is 0.6 down from highlights. And then we have 2 different ways of doing that. We can use a mask that is made out of everything that is black, basically, and with a high threshold, and you're basically injecting the original color on top of that mask, starting from the original image and then going on to the relit image, and then remapping that if we want to. If we don't have the dynamic range that we want, that's fine. Or what we could do was just using a batch average image or an ADA in node, which are part of the same node suite that I'm actually let me check if I have it somewhere over here. Maybe over here. Yep. I'm gonna link this one so you can find it. If you followed my workflows, you probably have this one as well. And so what we're doing is just trying to find the best way to color match. So this is taking all of the remapped images plus the original relit image inside of an image batch and then averaging them together as a mean with the mean value. There's also median, but median it depends. Sometimes it works, sometimes it doesn't. It's up to personal tastes, I guess. And this instead, it's another kind of averaging node that starts from the original picture and then takes all the batch average image results and then tries to average that as well with a mean. Any of you still following? Or do you care just about results? I guess you kind of care only about results, huh? But if you think this is good, think again, because if we have a vastly different picture, such as this one, from start to finish, where we start from a picture like this, let me zoom that in a bit for you. Hope you can see that. And we get like this neon blue kind of picture with the relit, with the IC light node as a relit image. Then we can't do that trick anymore, because the results are awful. They are really, really awful. I mean, we are still retaining colors, but we are completely destroying the dynamic range of the picture. So let's actually bring up our color match node without any of these and use this low frequency pass as a reference from the original image and the low frequency from the relit picture as a target, and hit Q prompt. And there you can see it's completely blown out. It's basically the same as this one, because this is basically doing the same thing. It's just color matching without remapping. And how do we solve that? I thought, well, I don't know. Do we have IC Light for SDXL? No, I wouldn't hold my breath for that. We only have for 1.5, and I don't think it's... Well, I would be very happy if it ever comes, but it really works well for 1.5, and you can... Like, these images are 800 by 1000, so like the way IC Light works, we don't really have that many constraints with optimal resolutions for 1.5. We don't care about that. So what I thought about doing, since I found that this wasn't working quite well, was trying some other stuff with this, which is basically the same as this one, but with a kind of neon light. And I thought, well, if it works for a close-up face, why doesn't it work for a close to full body or a full body picture? And I think it's because there's so much stuff happening. Like, a face is kind of fine to color match. If it's all zoomed in on face, there's not much happening around it. But it's not like it's working quite well. So with a full body. So I thought, well, maybe we should just remap it from, instead of keeping 0 as black, we just go down basically what it is, like one stop or a couple of stops in photography, which is remapping from 0 to 1, and then from minus 0.2 to 0.8, minus 0.4 to 0.6, so that the sum is still equal to 1 in absolute terms. You're just shifting the whole map range to the left of the histogram, and then trying to blend all of these together. But as you can see, it works quite well with the average node. It doesn't work anymore with the mask. So I kind of knew that the masking option was a no-go, because if it works well for just one use case, then it's not the way to actually go in order to solve all of this. The averaging with batching is kind of the road we want to be on. Do you follow? Like, does this make sense to you? So this is where we are at right now. Let's bring up this picture. I realize now that this is a very wide workflow and you might not be able to see a lot of it. Different between HM, other options in color match node, those are different algorithms. According to papers, the best one is the, let me bring up the node because I'm not using that anymore, color match. According to papers, the best one is HM MVGD HM, but that's all up to taste. Like, it's the same as when you are trying to see if two faces by using Face ID or IP adapter face look kind of the same. Yes, there's functions that tell you with inside face whether or not two faces are similar, but that's just math. It's also up to one's taste is. What I'm using instead is the color match image node that is coming from the GitHub repo that I have linked here in the chat, so you can look that up. So basically, what we ended up doing was just relighting with a very different light, the original picture here, and go, since the masking route wasn't quite working, was working with the remap range that as an absolute has a total amount of 1, that is from 0 to 1, from minus 0.2 to plus 0.8, from minus 0.4 to plus 0.6, from minus 0.6 to plus 0.4, and then use all of this as a multi-batch images inside of a batch average image node, and then batching the result of the average image node and the original and related picture inside of a new batch, and use again the batch average image node. So there's a batch average of this for picture that gets batch averaged with the original and the related picture. I don't know if that makes sense. I'm not sure it makes sense, but what we get is this one, which it is good in terms of dynamic range, in terms of coloring and color matching, in terms of details preservation. It is a very good starting point, at least in my own opinion. At least when we are coming from an image such as this one. Like, if you are looking at this image and this image, you can definitely tell that the color matching here is working. And now the only thing that's missing, talking about dynamic range, we have that kind of same dynamic range in colors. We don't have that dynamic range in lights. The histogram here is very, very squished. It's, let's say a normal histogram looks like this, but this histogram kind of looks like this. It stops here, and that's because it's just averaging everything together, and the related pictures don't have a very good dynamic range, and also these pictures don't have a very good dynamic range. So what we want to do is just remap the image, and remap, like the blacks are kind of good as they are right now, but the whites are absolutely not. This is a very toned down highlight picture, so we want to blow out the highlights a bit. Now, if I had a remap node that didn't go just for black and whites, but had also like a shadow and a highlight value set, that would have been great, because I would just be able to work on those instead of just blacks and whites. But I don't have that, and I don't know if that exists, so this is what I'm doing. And by blowing out the highlights a bit and the whites as well, we get something like this, which to me is absolutely acceptable. I don't know what you would say about that, but you can let me know in the chat. But to me, this is, if it's not a turning point, it is at least a starting point in color matching images without too many bells and whistles. Okay, if we have any dark shadows in input image, can we have control over shadows in generated image without IC light? Any alternative control method? Photoshop? I don't. That's like, how can you get control over a light that doesn't involve IC light? You could try and get control over light by using depth maps, but since IC light came out, depth maps are absolutely inferior to what IC light provides. So you can't really try and do that. What you want to do is just try to be as thorough as possible and as clear as possible with IC light and what it needs to be doing. Because if you're getting shadows where they shouldn't be, chances are your IC light setup is not understanding correctly what it should be doing. Like, for example, here, it's doing something very, very simple. It's just sourcing some light from here, from the mask here, and using that as a sort of spotlight. It's also natural light kind of a way. And the resulting highlights and shadows are correct. So it shouldn't really be that difficult for, at least for kind of simple lighting setups, for IC light to understand properly what's needed out of the resulting image. Okay, let me change this scene, because I'm gonna pull up my email over here, and I'm gonna place it up here so that you don't see my personal emails. And let's actually see the testing images from Mara Scott. I'm gonna copy the link, gonna put it right here. In the meantime, if you have any questions, you can let me know in the chat. Okay, I need a code for accessing that image. Okay, I've received the code. Let's see the code. Okay. Verify. Gonna go back to your question in a second. Download. And there we go. Okay. Gonna download the other one as well while we're at it. Okay, save that. Gonna take a look at the size of these images by Mara Scott. Properties, those are 2304 by 3072. Well, that's a very random aspect ratio. Okay. Let's see the questions. Okay. From instructions, does it mean we could convert an image with strong light source to like a top diffuse light and then relight with IC light? If that makes sense, otherwise I would need to find something else. I'm guessing the mountains one's better. Okay, let me check that. Let me first answer your question. If you see this image, this starting image over here and on the left, that's as harsh as you can get. I don't think you can get any harsher than that. Unless you want to just go completely blown out, I don't think you can actually manage anything harsher than that. So if this is fine for you, then yeah, like if this end result with the light coming from the side, from the other side, it looks good to you, then yes, absolutely, you can work with harsh lighting conditions. And also the details are preserved. Like we get the same details, we get the same kind of stuff. So I hope that's good enough for you, because I don't know, like we could try and blow this up, but afterwards. Okay, let me just let's bring this image over here from Mara Scott, the one with the mountains. Yeah, okay, there we go. I'm gonna botch the aspect ratio a bit because I'm gonna eyeball that. Sorry, but I'm not gonna convert that into an intelligible one. Okay, so we are hitting Q prompt. Now we're gonna get an error if we don't cancel because the mask is coming from here. Well, the aspect ratio is kind of the same, so that's fine. And where do you want the light to be? Let's say we want light from... The light's coming from here, so the lights should be around here. We want... What do we want? Sunlight. And let's go. Let's see. This is a very complex scene, so... We're gonna have to check. I'm not sure it works. Because that's also the thing about releasing workflows for the general public. Like, I am testing on images that are... the light's coming from the left side. It depends if you want to completely relight the picture or you want to build on the existing light. I thought you wanted to relight the girl on the bike rather than rebuild the whole lighting. Okay. No, we have to go way lower than that. Let's see, in the meantime, what we get out of it. I mean... It's not perfect, but as a first test, it's not bad. We didn't even remap it. Doesn't introducing contrariness workflow changes in lighting conditions, and even if we use IC light? Well, if you add a depth control net, depth will be taken into consideration a bit more than they already are, but it's like the way IC light works is already doing, if not a depth estimation, at least a normal map estimation. So it's if the lights and shadows are wrong with your generations, chances are you have to rethink how you're doing relighting with IC light. There shouldn't be anything wrong with the relight. Like even here, I didn't give it anything. Like there's no depth estimator here. The light's just coming from, like, the light here, it's correct. It's everything's correct. Shadow from the compositing... The bicycle lady. The shadow is here. So the shadow was already here because Marascot already had some shadows, but as you can see, there's also a tiny bit, like this girl is very, very tiny in this image. No, the shadow doesn't seem to extend. At least a bit. No, there's a bit of shadow here. It all depends on what, like how much you want. Like here, there's some more shadow. It's taken into, well, it's coming from the left. So there's no shadows to be redone. Like it's, let's do that from the right. The way I placed it, the shadow is from the left, from where it should be. Open in mask editor, let's do that again, but from the right side. This should change radically everything in the picture because here all the shadows are coming from the left side towards the right side. So if it works, it should recalculate everything. Also, I don't understand why you are so hard bent on trying to complicate your own life. If the light's coming from the left, why are you trying to make it come from the right in such a complex scene? Just flip the image over. Let's see how it works. Nope, it can't do that because everything is so difficult to understand here. Let's see if by adding, like, I also have a depth control map here, so you should pick that up. Oh no, that's fine. No, I'm not saying it's wrong. I'm saying that the way I usually think about this kind of things is that I try not to overcomplicate stuff if there's an easier way to do that. So the relit picture is not picking anything up from what it should be doing. So let's do that instead. Let's add some light here and see how it works. Because we have to find a way for IC Light to properly understand what's going on. Now, I don't think it's random that on the IC Light GitHub page, most of the testing that was shown was done on portraits. But we're trying to do something entirely different here. So that might also be it. Yeah, no, it's not picking anything up from the background. It's not understanding that. Let's crop this image actually. Let's do this instead. Oh, here's my thumbnail. Let's crop this picture since it's very, very big anyway. Let's do a 4x5. Let's see if this works. Let's bring that in. Oh, sorry, here. And let's switch the height and width. Not 8,000, 800. And let's see how that looks. Want the light coming from here instead. Let's hit Q prompt and see. And that's also kind of the thing that happens when you try and do testing with a lot. Yeah, okay. It's starting to get what we want from it. Let's see how this works. Like, you are releasing something to the general public that it's very clear in scope in what it can do and what it cannot do, and then the users try and make it work for something that it's not supposed to be working for. And it's, yep, it's still picking these shadows up, but it's making these shadows go away. So let's see the relit image. So right now, by averaging everything, we still get way too much of the shadows over here. So we would need to, also the remapping is all wrong because that's not automatic, but so we would need to work on that, and that's great to know. What I'm sorry, Sai. What do you need by what do you mean by crisp? IP adapter doesn't add crisp. IP adapter adds either a style or embeddings so that your resulting picture is conditioned by the embeddings. It's not about details. It's about having a sort of reference. The crispness of an image, well, style, yeah, style would, yes, but it's like, what's the style of this image? What you don't want to change the original picture when you're doing IC Light. You want to keep the original picture around as much as possible. You just want to change the lighting. So you don't want to add stuff that changes the picture. You just, like IC Light, the way it's, at least right now, it's implemented aside of workflows. It's basically always at the end of a workflow, because you are supposed to have a picture that is already good and you just want to change the lighting. So at the point you are inserting IC Light, you don't want to change anything else. Like, you want to keep the details, you want to keep the colors, you want to keep everything around, you just want to relight stuff. Okay, so what's needed here? Let's try with this simpler one and see how that works. By the way, thank you all for testing with me today. Like, this is great. This is all data that I can use with 800, and that's why I didn't release this as a video, because I knew that some of you would come out with different use cases that I didn't think of, because I'm mostly a fashion photographer and I think about fashion photography stuff. Yep, this is way better. We still pick up some leftover shadows here, but there's new shadows here, there's new highlights here, there's new shadows that are at least make sense with the new kind of lighting. There's new shadow for the car over here. So let's do that for the whole picture now and see if that works. Okay, let's switch these dimensions and hit keep prompt. Of course, yes, because you don't have a mask. I don't know, the light's coming from here, I guess. Okay. Yeah. This image is way too complex for IC Light. There is no way to understand what's going on here. Like, it's kind of understanding what's going on in the background, and it's trying to make sense of what should be here since now it's lit, but it doesn't nearly have enough to work with. Like, these kind of harsh shadows, there's no information in them at all, so it can't really try and make sense of that. Let's try adding a control net for depth and see how that works. I have it right over here. Let's add that. I'm just gonna place it randomly right over here. Pardon my mess. And I'm gonna use this image as reference, of course, and I'm just gonna add a preview image just so I know that it's working. There's just a simple control net depth with adapt anything preprocessor. Didn't quite pick up a lot out of that, and that may well be the reason why it's not understanding how to light it up properly. Let's add a Zoe depth map and see if that changes something. Would two sources of light make any difference? Here, no. I don't think here the main issue is the sources of light. I think here the main issue is the complexity of the scene and the amount of stuff that is going on and how far out it stretches. Like, it's the depth map that we're looking at least for the one from Depth Anything. Now we're trying with Zoe. It's not picking anything up but the girl on the bike, the road in front of us, and the car. And even the car is not that great. Also, you can't really have two sources of light here, because this scene is only lit by the sun, mostly. Okay, let's wait for Zoe Adapt to actually take its sweet time. I mean, there may be better preprocessor. That may be a Marigold preprocessor. There may be Midas who would yield better results. Adapt anything is just my default go-to. Come on, Zoe. Oh, it's that. Oh, I've never used this Zoe. Oh, that's why it was downloading. Well, it's almost finished. We'll actually try with more than one light source afterwards and see how that works. Okay, almost finished. 2 seconds left. Another email with another example. Yeah, something more in my area of expertise. Okay, let's save this one. Can you try with Zoe anything which has indoor and outdoor settings? Zoe anything. Yeah. Okay, well we're getting better results. Okay, Zoe Adapt anything. Let's try that one. Outdoor. Let's try and do that. We are still getting kind of nowhere even with Zoe. And let's try with oh, it's downloading this one as well. Okay. In the meantime, like how in Blender we add accent light just to enhance other light, since the image has our shadows, one closer and one further away. Yes, you could do that, but the thing is, natural light doesn't really work that way. Like you could do that, but at that point you would be trying to do something else, which is advertising photography, which is fine. You can absolutely do that. It's just, let's actually try and do that afterwards. But you're never gonna have two suns. You are just, like if you have a spotlight here, it's coming from a studio light over here. It's also kind of a matter of how things work in real life. At least to me, I guess. It's the way I work photography-wise is just trying to emulate what goes on in real life rather than trying to add stuff. And that's also why I was asking about why would you relight this scene in a completely different way as you normally would. Like, yes, you added a girl on a bike. Every single light in the scene and shadow points in one direction. Why do you want to just reverse everything from the other side when it would be a lot simpler to just add one light from where the light source is coming from? And funny enough, yesterday I did a one-on-one about this and with one of you viewers, and we talked about the same thing. Like I said, yes, if you are trying to relight a product inside of a complex environment, you are shooting yourself in the foot, kind of, because you, like, why was that complex environment approved in the first place? Yep. Let's actually try again with, well, actually, let's try with Zoe that map, which was working better. And let's clear and start again, but this time with a big sun coming from the left side. And let's see if that works better. Like, it's also kind of about knowing the limitations of what you can and cannot do if you are selling solutions to clients. shadow issue is my homework. Yeah. It's like these shadows are hard here to make a sense of. Let's use one of the other pictures that I got by email. Let's use this one instead. And let's actually see what I mean. Okay, so this one looks like it's 2x3, so that's gonna be 800 by 1200. And let's hit Q prompt again, cancel, so we can add a mask, open a mask editor, and have a very harsh light coming from here. Let's do harsh spotlight, and let's see if that works. Because then we can see the differences between trying to, well, actually I'm gonna put that off screen a bit so I can see if it's not safe for work. Okay, it's not safe for work, so that's great. Okay. Let's add a compare node. And let's actually run it here. It's a lot easier to compare it here. So that's 800 by 1200. Q prompt, cancel, add from, I don't know, here. I'm hiding it just in case. Once I know it's safe for work, I'm gonna hide it. Yep. Okay, so we didn't get a proper relight. We have to change something because the light is basically the same. It's just that it's more contrasty in a way, but that's all. Basically, so we want to do some better masking so that we can get a proper relight. Let's do something like this instead. Let's see how that works. And after this, we'll do 2 sources of light to see the difference. Yep. Okay, we got some relighting. Okay, right now the average is working a bit too much. You can see on this face here, is the depth resolution missing shadows here? What do you mean? Depth doesn't care about shadows. Depth only cares about depth. It's not about caring about shadow. Let me bring up a preview image node here. There you go. The depth node, the depth preprocessor doesn't care about shadows. It only cares about depth. And the way it estimates depth is both by highlights and shadows, of course, but also by other stuff. And it's the shadows are and the highlights are an indicator of how the depth is working inside of an image, but it's not extracting light and shadow information out of a picture. It's like, it's not working like a normal map works. It's working like a depth map works. And that's why you have your face here. Like, it's, and the neck here, it's not because the neck is in shadow, it's because this is how a face works. And if you were to look at this, like the original picture, the overall light on the neck is basically the same as the one on the cheek. So if it was caring about light and shadows in terms of hex values, I guess, it wouldn't create this kind of depth map. Okay, let's go again. So what we see here is a relight of the face in the front, not so much of the one in the back, and that's because it's averaging a bit too much from the original image. And that's fine, that's good to know. I will actually try and fix that later. And the harsh light here is not being redone in any way, shape or form. Let's see if that's an issue with the relit picture as well. You don't see that as much in the relit picture because the shadows are really crushed. But if you wanted to color match, I guess I would need to account for that. Yes, that's good. That's very good to know. Because we're sourcing a lot of information from this one. I guess we want to do the same but opposite for the one from the relit picture as well. That's good. That's good. Good to know. Okay, let's do that with 2 light sources now. And let's say one is coming from here. Let's do strip lights. Well, let's do softbox spotlights. Let's hide that just in case it comes out not safe for work. And let's see what's happening. Mara Scott, sorry man, hey Andrea, I wasn't supposed to be doing this. Shadows, however, you got me excited. We can really realize it. Ah, okay. Well, Mara, if you are still here, no worries. That's absolutely fine. Okay, it's not safe for work. We got 2 images. The relighting is not great at all, so let's do that again. Let's do neon lights. Usually that's way harsher than that. Yeah, Mara, don't worry. Like it's when I realize I come off as harsh sometimes. It's just me thinking with you chatters. It's not about shutting you off. It's about trying to understand what you mean out of it. Like if it's something that is vastly different from how I think about things, it always gets a bit confusing for me because I didn't think about that, and that's why I'm doing this, because I just want to test things out. Oh, come on, dude. So this is a very strong limitation with IC light, which is just trying to make it understand you want something in front of a subject. Let's do it like this. From the side. Neon lights from the sides. Let's see if that works. Let's see how that goes. This is a photo you're working on. What I'm trying to figure out is how to keep the subject face the same in the final image when trying to put them into an alternate location like a cathedral. Well, that's really easy. Well, we actually just solved that. That's fine. But what I'm trying to do, I'm going to show you how. But what I'm trying to do is actually relighting them from the front, and I'm from the front. Let's see if that works. In the meantime, I mean, depth maps are used. Well, at least they were used up until IC Light came around, and they're still used in order to relight images. Like they are, at least in Stable Diffusion, they work quite well, whereas normal maps usually don't work quite as well. Having a depth map is useful to recalculate light afterwards, but you're not extracting light and shadow. Like it's not like a depth map is the limiting factor in shadow and highlights. It's much more about having the generation take into account that you don't want the same highlights and shadows anymore, and we are not doing a proper image-to-image workflow here. With IC Light, we're doing something different, so that's where this issue comes from. Okay, so let's go to the detail. The details are fine. The details are absolutely there. It's just a matter of using a frequency separation technique, which is this one. You are basically using the original image here and splitting it into an high frequency layer, which is this one with all the details. Can you see them? I know it's a bit rough to see on a monitor, also when I'm streaming, but you should be able to make out the outline of the subject. And we separate that into a high frequency layer for details, low frequency layer for light and color. And we do the same for the relit image. Now what we want to do is, well, at first we wanted to use the low frequency layer from the relit image because it holds light and color, right? That's what we want. And put it together, blend it back together with the high frequency from the original image, which holds the details from the original image, the ones that we don't want to miss out on the relit image. And it would be very easy if it worked just like that. But the thing is, we also might want a color match. So that's what this is all about. If we want to just keep details and we don't care about color matching, then yes, it's absolutely solved. We can do that by just using frequency separation technique, and that's kind of all. Like that's really easy. But as long as we want a color match as well, it gets a lot harder, because what you're trying to do is have a sort of average color matching between the start and finish, but obviously light affects color as well, and IC Light has a very high color cost component to it. Like it usually, let's do white lights. That's actually the blue neon light for starters. And also today we learned that IC Light is absolutely terrible at relighting landscape scenes. So that's something new that we learned. I didn't know about that. Okay, yeah. So the thing is, if we want to color match between these two together, what's gonna happen is that we will have to influence the color for everything, because we are not using masks and segmentation like we are doing in Photoshop. It's a lot harder than that. So what's going on over here? Oh wow, that's okay. What? Well, we'll take care of that later. Okay, what's happening? We are also working on other stuff. So we want to find the middle point where we don't get these artifacts for sure, but we get the color matching on the people, and we still get the relighting. And we are kind of getting it here. If you look at the eye here, we are still kind of getting it, because we're getting the shadow. We are getting the bit more of a shadow under the chin. those things we're getting, like the new shadow here beside the lip, we are getting that. But we are also missing other stuff. So that's what this is about, trying to find the right middle ground for it. Why are we having red color? I don't know. That's a first for me as well. That's the magic of doing things live. I don't know what's happening here with the red. Let's actually troubleshoot that. Let's see where that is happening. Let's hit Q prompt here. Okay, it's happening here still. Let's do that for the remap. Okay, so it's happening somewhere here in the color matching thing. Let's lower the blur. This is a value for the blurring that we are applying for color matching. Yeah, and we get rid of that. It was just that. There we go. We are not getting that red anymore. So it's color matching still. It's not a huge change. It's not like relighting a lot. Let's actually try and do something a bit more extreme. Let's bring up some of mine. So I want to start from, let's see. Archive. There's one, body sample. Okay, the one from outfit anyone. That's a good one. 1200 by 1200. Yes, that's fine. Let's hit Q prompt. And let's cancel because it doesn't have a mask. So no need in actually going forward. We want to have, let's say we want to have some light coming from this side. So right now the light's coming from the right side, right? We want to light it from the left side. So let's do blue neon lights from the front, from the side. And let's see what happens. I'm still thinking about how to relight backgrounds. I mean, landscapes and stuff that doesn't have like a quite as much depth information as a close-up picture. That is a good question, how to do that. Yep, she's not nicked, right? Yeah, she's not. Okay. Yeah, there we go. As you can see, we start getting some very, very, very bad results here. Because the two images, the starting image and the resulting image, have two completely different histograms. Like they're one's all the way to the left, the other is all the way to the right. They don't really match. This one, the original image is a lot softer, so the histogram is more spread out. The relit image is completely to the, it's like the starting image has an A-shaped histogram. It's like a dune, whereas this one is like an U. It's like how do you call those in the skate parks? It's like that thing. So they are completely different. They're radically different. Well, Sai, I am using Epic Realism. I've tested Photon as well. I've tested some more 1.5 models. They're basically all the same. They're all merges. But there we go. Like, if we average those out, we get to a point where we get some better results. But by averaging two such different pictures, we are not really getting like the picture we want, right? Because yes, here we have the catch lights from the left, from the neon light, but it's an average sort of picture. It's not a completely relit picture. You can see that here on the shoulder we have a new catch light. Here on the chin we have a new blue catch light. But it's not exactly what we wanted. We wanted to change the light completely like we did in the original picture. So what we might want to do is just try, let's go back to square one. Let's do some color matching starting from the two pictures, the reference and actually the reference is the starting one, the image is the relit one. And we want to start with 100 as a factor and preview image. And let's see what's going on. Yeah, it's completely destroyed. Like, these two histograms don't talk to each other. So let's randomly go up and down the blur size value and see which one works best. Neither of them might work actually. Well, a lower one is starting to work. Let's go all the way to 0. Okay, so 0 is basically the original picture with some of the detail from the one that we are starting from. So let's try to average that out. Let's use that as an average. So what we want to do is just get this batch average, place it right over here, use that one, and the original one, for example, let's say. I'm testing this thing in, like, for the first time myself, so it might be right, might be not. Yep, we are getting somewhere. We are most definitely getting somewhere. So this bar here, and to a lesser extent this bar here, which you might not see but it's there, those are there because of the depth map, and they're there even if we don't have a depth map preprocessor. IC Light picks that up, and that's a matter of the source image. If I were to fix that image in Photoshop, actually I might do that right now so we don't get that anymore. We don't get those bars, so ignore these two bars for now. But right now we are color matching quite right, and we are preserving details quite nice. So this might be superior actually to actually just averaging out stuff. Actually good. Actual progress. That is nice. Okay, let's test with another one. We are making progress, chat. Are you happy? Okay, let's use, I don't know, let's use this picture instead. Okay, this is 800 by 1000 is my guess. Let's, oh well, I keep forgetting its height and width, not width and height. Because the thing is, you see my videos and you see everyone else's videos and you think, oh well, that's easy, man. They made it sound easy. It's just, you do that, you hit Q prompt and that's it. But you don't see all of the unedited footage where I scream at my monitor and I say, what are you doing? Please do not leave me. I can change. I can be a better man. Please do what I say. You only see the good results. Okay, let's go. Let's see how that works. Like, for the chatter who was talking about shadows and highlights in the depth perception thing part, here, like the original image, let's bring that up over here. There's a strong highlight here and a strong, like, it's not a strong shadow, but it's still a shadow over here. If the depth map would think about depth as a matter of highlights and shadows, this part here would look a lot darker than it is here. Okay, there we go. Yep. Color matched. That's fine. We're still getting a hard shadow from here, but we're getting the highlights here. So that is quite nice. Let's try and make it do something different. I wanna highlight here. Let's do some Gaussian blur. Let's see if that works. Maybe that blur is not enough. Let's hit another Q prompt. And also I am discovering new stuff every day as well. I actually tended to discover a lot less stuff before opening this channel because I didn't have to force myself doing stuff in order to create content. But as I have to keep creating content because otherwise you would not like me anymore, I am trying to understand new stuff and learn new stuff every day. You don't understand what I'm trying to do, so let's force your hand just a bit. Ferenc, the way the light source is defined freaks me out. Where does that light come from, back or front? I don't know. It never comes out where you want it to come out from. It's always a matter of, like, with Stable Diffusion and generative AI in general, it's always a matter of trying to make it understand what you're trying to do, and it's very often not happening in the first time. Let's do like a whole huge thing over here and see if that works. I don't know if I can be more clear than this. I see light. Let's try to keep things civil around here. I don't know if the AI are yet capable of attacking us, at least to like. Icy light is definitely not capable of doing that. Okay, let's. I know when I have to throw in the towel. Let's try another light. Let's do it with this one instead. Diffusions are unpredictable. We don't know which direction, but yes, that's the thing. Like that's what I was saying during the previous live last week. We're trying to make it understand inside of a 2D space where the light should be in a 3D environment, but it's only an approximation of it, and we can also only move in an XY grid that is confined by the picture that we're working on. We can't go over the borders of our pictures, and there's no Z depth that is understandable by we cannot place the mask anywhere on the Z axis because there's no Z axis. Let's do it like this. Let's see how that works. Okay. Yep, for example, for this one, it doesn't work at all. Like, it kind of works, but it doesn't really. It works really well with this one instead. Like, if you take a look at the light over here, which is being relit, it's beautiful. But it doesn't work with the thing that was working up until now. It is kinda, it's just not great. Let's do that again with another kind of. Let's do two different sources of light. Psi, I don't know. I haven't looked nearly enough at the at SD3. I was waiting for it to come out before actually delving too much into it, because I didn't know what to expect out of it. So I just... The only thing that I know is that it's using a different architecture. It's not using UNet anymore, if I'm not mistaken. And this is a UNet model. IC Light is a UNet model. So I don't... for sure, IC Light will not be usable with SD3 unless it gets a complete rework. Like here, we're getting a nice result. The light on the fabric is being completely replaced. And on the face as well. And that's the kind of thing, like, this brings me back to the beginning. Like, how can I test for every single different use case out there, different kind of picture, different lighting situation, different relight situation that the user will put eventually this workflow through. And that's why, like, in my previous workflow, the one for product V4 of the product relight workflow, I released it with 3 different color matching groups, because I couldn't find just the one group that worked well for every single use case. So I might have to do it for this one as well. Like kind of the same thing. Just say, okay, here's 2 or 3 different relight options. See which one works for the picture you're trying to generate. Because it doesn't... I mean, it makes sense in the sense that it's a matter of matching histograms, but it also kind of doesn't, because, like, yes, they are widely different lighting situations, this one and the previous one, but there's not like a definite way of doing things right here. Like, to me, this is good, but if you were to go for a completely different way of doing this, that would be good as well. Like, this thing works, this thing works, this thing doesn't, and I know it doesn't. So this thing is... It's a bit of a mess, really. You can't make sense of what works and what doesn't. Let's see if I have another example that we can work with. Let's do... I'm trying to find a picture. Yeah, let's do this one, why not? This is 2 by 3 if I remember correctly, so that's 1200 by 800. And we want to do, well, first we hit Q prompt and then we cancel and then we open it. Oh, it's not. What are you? 4.5 by 6? No. So you are 800 by 1000, I guess. Oh, you didn't look like that to me. Okay. So let's see. Want some light from here. Like, change it drastically. And see how that goes. Yep. We are getting a ton of red out of it. And that might be a part of the issue why with backgrounds and not enough information is in the shadows, we don't get something good out of it. It doesn't really understand what's going on there. That's the spotlight. I want to do a spotlight here. Let's do, well, actually, let's do sunlight. It understands sunlight way better than spotlights. Let's try and do that. Can we have capable to take 2 light sources inputs such as, hold on, 1 point light and a neon light with IC light? I've never tried. Let's try that. I've never actually tried to do that. Let's do that afterwards. When we have sunlight and neon light. I don't know if there's a way to actually influence that, but like which one is which, but yep, this is a good enough result for me. It's not the complete relight that we have here. It's an average, but at least we are keeping consistency with the colors. Should you try to prompt it more closely to what it is in the picture, like black clothes, pink background, plus the difference in the lighting source? So, let's try that. So I've tried a lot of different prompting styles. Let's try it with an empty one. I cannot get it to consistently understand what I want from it. And that might just be me not being a good prompter. And I can openly admit to that. But the thing is, as you can see, even by not telling it what I want it to do, it still understood that that's a light map. And that should be light. And there should be light. So, it's, I don't know if prompting, let's actually try that, but I don't know if prompting for what I want it to do is the way to go. But let's try and do that. Photo, close-up photo of a young blonde woman wearing a black paillette, it has 2 teeth, oh, yes, that's because it's paillettes dress, red backdrop, natural light, sunlight shining on her face, and let's see what happens. Yeah, nothing much has changed though. In my experience, the conditioning from the prompt is not as high as the conditioning from the original image. That gets encoded and used as a latent inside of this node. The positive prompt goes in here as well, but what comes out is just a positive conditioning that takes into account both the prompt and the latent image that's coming in, and that's the encoded image. It says the encoded original image. And yeah, in my experience, prompting to, like, there's a limit to what the positive prompt can do. Like, if I were to say, let's say, green neon light, it would probably understand that. Yep, it does. And even this color matching is not that bad, honestly. It's not exactly bad. And it's much closer to what we get out of the averaging stuff. So yeah, it's just a matter of tinkering and testing things out and trying to understand what works and what doesn't, what are the limitations of it, what can it work with, what it can't work with. Like today we learned that it's not working quite well with landscapes. And we learned that it works quite well with portraits. We learned that if we average out too much of the original picture and the relit picture and all the different remappings, it works, but it's not exactly what you wanted from the start for some pictures. For others, it's better to just use the average method. For others, you just throw a picture in there and that's it. It's all a matter of trying things out. Like if we go back to the original picture that we had, which was this one, for example. Let's do 1200 by 1200 and hit Q prompt and cancel and open a mask editor and do this here. And let's do 2 light sources. Let's see how that works. Let's see. Can the light definition cause issues? By drawing random masks, the result can be more unpredictable and uncomparable. About to use simple prompts like from the left. No, you still need a light mask. You very much still need a light mask because otherwise it doesn't work. Like, let's say we wanted to. Well, let's actually try and do with an empty latent image because I've seen that done sometimes, and I don't understand why you would do that. So let's actually try and do that. Arch spotlight from the left. But let's first compare this one and then do that. Like here, it's the simplest way of doing things. You're just averaging out all the different remappings with the relit picture, and you're just using this average, and then you get the color matching. Easy, done in one click. Whereas with something like this, you'll have to try and understand which method works best. Let's hit Q prompt by using an empty latent image here. I want to see what happens. I think these diffusion models don't have an understand about positions such as left, right, and I don't think so. It will not understand. Let's see. I mean, we're testing, so might as well try things out. We might be surprised after all. Yeah, it doesn't really understand that. And this is the kind of thing that I was talking about this on Reddit, I think. I saw someone using an empty latent image and I said, why are you using an empty latent image? Like, an empty latent image doesn't have a light mask in it. The way I see light works, it uses an encoded light mask in order to have a starting point for the image. Like, let's say, and that's why I use denoise 1. You can get away with denoise like between 0.9 to 1, but let's go all the way down to 0.5 for denoising. And if you do that, you can see what I'm talking about. Yeah, we are getting the light mask because that's what's encoded and used as a latent. We are starting to get an outline of the subject, which is not in the latent, it's in the conditioning. So that's why if we use an empty latent image and we try to give it directions with the prompting only, there is no light information in the empty latent image. Or if there is, it's just completely random. And I would say that 99% of the time there's no light information at all in an empty latent image. So that's why I want to go all the way to 1. Let's try with 0.9, how that works. 0.9 should be enough for it to understand what we're trying to do. It should already projected the original image on top of the light map enough to make sense of it. Yeah, we're still getting something. It's not perfectly done yet. If we go all the way to 1, we get a better picture overall. But it's still, we still have to work within those limits, right? Do you understand what I'm saying? Yeah. We're still getting much of the black that was encoded in the latent, and it wasn't done quite yet. So yeah, I think this is the spot where we are at right now. It's not done yet. We still have to do much testing for it to be properly done, and I had some good results with 1D noise, with empty latent for changing background completely, not necessarily for changing lighting sources, but lighting will make sense while preserving the subject. Yes. If you want to use a background, then yes. I ended up moving away from the FBC model of IC Light, which is the one that lets you use the light from a background, because I found that it had too much of a color cast on the subject, and that's why I barely use it anymore. And well, yeah, if you're using a background, then yes, it would work. But if you are relighting without a background, you absolutely, I think, at least I would say you would absolutely need an encoded light mask. But with prompting, I think it works without the background. Does it? Let's do that. Empty latent image. Do you not use a light mask at all? I'm interested in that. So let's say sunlight. You can use it. Oh, well, yeah. You can use it, but no. What do you mean? Wait, I will wait for you. Let's build it like you would. So in this case, we have our original image. Do we want to use a light map from a mask or not? But you need to prompt the background and the subject. Yes, no, absolutely. But so starting from an empty latent image, right? So in this case, we want, for example, close-up photo of a young man with short hair and beard. Trees in the background. I'll say out of focus trees in the background. Out of focus trees in the background. Light, sunlight coming from the left. Lighting up his forehead and hair. Let's do it like that. Oh, no worries, that's fine. Like, if you test too much alone, you don't get to try out different stuff. I normally use the multiplier a little higher, but I don't know really. Oh, well, yeah, you can definitely do that. Let's do that. Let's do 190. Oh, 0.25. Okay. Not seeing any changes. Do you give it a direction or what? Like, yeah, it's evening it out, but let's do a neon light. Blue neon light. Like, it's spreading out the light because as a light map, it's using an empty latent image, which is, well, empty. Yeah, we got some blue tint because we asked for a blue neon light, but it's not like, yes, it's a bit harsher maybe, but, and it's coming a bit from the left, but I don't know how much more I can. Let's go all the way to 0.5. Let's see how that goes. Well, it's actually, maybe it's a CFG issue. You're using a higher CFG maybe. Let's go down to 0.25 and ETQ prompt again. Because I am using very low CFGs. So that might be it. Oh yeah, if you are using a high CFG, then yes. But I find that with higher CFGs, the resulting subject tends to be a bit more different than the original subject. Yeah, I mean, yes, changing the CFG definitely works, but the resulting subject is a lot different here. We might be able to see that when we are transposing details. Yes, it doesn't line up quite perfectly anymore. And the image looks a bit overcooked, in my opinion. Let's go to 2.5. And it also doesn't quite direct it that well. Like, it's not only about quality, it's also about preserving details, preserving the original details of the pictures, not in terms of fine details. I'm talking in terms of colors, of what makes the original image, I would say. Oh yeah, well yes, you can do that in order to preserve the stuff. The thing is that if the original subject gets too far away from the relit subject in terms of colors, lighting, no, not lighting, sorry, details, position of the details as well. Like, you're using a line art, so at least you get that consistent. But yeah, it's, if you don't use any of those, then yeah, it doesn't quite work well. But yeah, that's a great point of view, actually. Like, yeah, you can see that we get better results if we use also a light mask. Like, it's much more precise in what we want out of it. And even in the fixed version with color matching, we get a better result out of it. It works better, I think. This is a bit too harsh for my tastes, so let's actually do that with this workflow instead. I'm gonna copy all of these. I'm going to bring them over here, and I'm going to use this as inputs. Okay, now this one should be that one, and this one should be the original resized one and the relit one. Let's see how that goes. Oh no, got it wrong. This one. Let's go. Yeah, that's better. The comparison one is this one. Getting somewhere. Also with Hive CFG, we got this branch, which wasn't there first. So we're getting like a shadow of the branch here when we are color matching. That's also something to keep in mind. Like with higher CFG, it's trying to make it all work. So yeah, we might need a few more control nets to keep that in check. No, I mean the details are all there. If we zoom in a lot, the details are all there. And that's because the high frequency layer took care of that. Like this is the original, this is the relit. This is the original, this is the relit. Not original relit, like the actual original. Relit, original, relit. And even in this one, which is not an average, the results are, the details are still there, even in the relit one. So yeah, I think this is the extent of where we can get things to right now. I will have to decide on a way of present. What's the iFrames thing which maintains details? Okay, so let me go back to the start of this. This link, copy link address. So you can find a frequency separation node both in this GitHub, which is mine, and like it worked. What? Wait a sec. Where is it? This one. There you go. Or in, where is it? There we go. Or in this one, there's frequency separation nodes. And what you want to do is separate a high frequency and a low frequency layer. Let me zoom in a bit so you can see some of them. Let me actually up the blur radius a lot so you can see that. Yeah, so here we have your details from the original picture, and you have the blurred picture, original picture with color and lighting. And here you have the same for the relit picture. You want to basically, if you don't want to keep the details from parts of the relit image, you want to discard this one completely. You don't care about this one unless you want to keep them around in some areas, in which case you need to have a mask and create a new high frequency layer, which is the blended result of the two frequency layers based on a mask. But let's say you don't want any details from the relit picture, which is easier. You just disregard this one, use this low frequency layer as a base. Let me actually frequency combination HSV node. You just put the low frequency layer from the relit picture and the high frequency layer from the original picture, and what you get is a relit picture. Well, this one is bad because it's not in the same range, but let's go back to 5, I guess. Oh yeah, because it's not remapped. But what you would get if you were to go through all of this instead of just going straight for a combination would be a picture that had the relight, color, and lighting of the relit picture and the details of the original picture. But you have to do quite a few more steps than that, and that's why they get combined here instead of straight away. Also, it might be because I'm doing HSV, whereas I should just do frequency combination node. Maybe they are RGB and they're not HSV. Yeah, that was it. As you can see, you get the details from the original picture, and you get the relit colors and lighting from the relit picture. And if you don't want a color match, this is the end of it. Like that's kind of the point. I'm doing all of this because some of you are very naughty chatters and very naughty viewers, and you want to color match everything, even if it doesn't make any sense to color match stuff. Because if you didn't want to color match stuff, I would be finished. I would just release these nodes, tell you to just combine the low frequency and the high frequency from the two different images, and that's it. Let's call it a day. But you don't want that. You want a perfect color match, and you're not satisfied until you get it. Huh? It's always the same with you, chat. Where can you get this workflow? Nice. Well, you can't yet. I will maybe. Yeah, I will upload it tomorrow. And I will post an updated version of it next week when I release a video for relighting people while preserving details and colors. And I just wanted to test things out with you and understand the limitations of it, and understand what was going on, what was happening, what was right, what was wrong, and based on your examples as well, because I didn't know if my examples would be enough to actually test things out. Like as we learned today with Marascott, we can't properly relight landscape pictures, and if I release the video that said, hey, you can relight anything, don't worry, and then Marascott downloaded it and tried it out, it would call me a big fat liar because I had said that it would work for everything, and it didn't. Okay, thank you all very much. Thank you, Obsessive Interactive. No, thank you for watching. It's my pleasure to have all of you chatters and viewers here taking care of me, and yeah, I guess I will be seeing you next week. Same as always, I am Andrea Baioni. You can find me on Instagram at Rizunobushi or on the web at andreabaioni.com. If you haven't seen my previous videos about this subject, there's a ton of them. Please start from the latest and not from a random middle one, so then you can ask me, how do we color match this thing? And that we took care of that in the latest video. Okay, bye bye everyone. Hope I haven't been too sassy, and ciao ciao.